So I've got a part we need to make today. Part will be about yay big. It'll come out of this bar of 6063 aluminum. This is for a new customer, and so I want to do a really good job. And plus, I need to get this done today. Technically, it's not due today. I still have several days, but for my schedule to work, we need to finish this up today. Now, if any of you have watched Inheritance Machining, you'll know that every good machining project needs a side project. So to start with, we're gonna start with our side project. This is a 3-jaw chuck that I've had sitting on my shelf for about 6 months at this point. It used to live on this micro arc 4th axis on my Tormach, but at this point I only ever use this ER40 collet holder. But I make stuff out of round stock on the Haas all the time, where I am sticking it straight up like that. Right now, the way I've been doing that is by making soft jaws like this that just have a round cutout, and I just clamp it straight up and down. That method both requires the time to make a new set of soft jaws, and it also requires the materials it being invested into the soft jaws. So by switching to this 3-jaw chuck, that'll save just a lot of setup time on a lot of the parts that I make. Plus, if I ever needed to in the future, I can buy another one of these cheap Far East Asian import ER40 chucks and use that as well on the same, either the same base plate or another copy of one. I have this big chunk of stainless steel that I'm going to cut down and use as my base plate. And then instead of traditional dowel pins, I'm going to use these locating studs for locating this on the Saunders Machine Works fixture plate. These have a nice dome to them, which makes them really, really easy to get in and out of that fixture plate, and they are by far the best locating studs that I've ever used. Every time you buy a new set of the Flux soft jaws, you get a new set of locating studs, so they're basically free. They're something I have laying around in excess, so I might as well use them on this custom fixture. Should I just go ahead and make the part instead of making a custom fixture to make the part? Probably. I don't really need this. But if it saves me 20 minutes or half an hour a week, every week, forever, like that'll pay itself off pretty quick. For making this fixture, I'm going to be using the classic jump out of the airplane and build my parachute on the way down method. This is something I do all the time to save some time on parts like this. So while the saw is running, I'm going to go keep working on the cam. I was able to drop the part into my cam templates, and that got a large portion of the cam work done, but not all of it. And it's just going to take me a while to get the rest of it done. But while it's running, I can get the machine roughing out. I can get the material sawing. So even though I don't have the whole process nailed down yet, we can get some of the stuff that happens every time, and it's very predictable, like a 3D roughing strategy. We can do that while I'm doing the cam. That way we're parallelizing tasks instead of serializing them. And that just helps get things done at a sooner time. So nothing particularly special about this setup. It's a chunk of material in a vise. The only thing notable is I have changed the position of my work coordinate system. It used to be this top left corner of the material. I have since then changed it to be in Z as the top of my parallels, or the built-in parallels on this mod vise. And then it is this corner of the vise. So not of the material, but the corner of the vise. And that way it doesn't change every time that I set up a new setup, and so I don't have to waste time touching it off every time I run a part. Again, this is nothing crazy, this is nothing new, this is nothing that normal people in normal shops don't do, but it's something I wasn't doing because I was used to having probing, and it'll save me 30 seconds a day for as long as I'm machining. That adds up over time. It was a little chattery around the corners during that first stage of roughing, but seems to be doing pretty well now. So I'm going to leave this for about an hour, go eat dinner, and hopefully nothing will be catastrophically long when I get back. Oh, and actually, you may have noticed things are a little bit rearranged since the last time we shot a video. That is because we replaced the old jail cell with a brand new, like, actual fully enclosed wall. We don't have a door yet, so I've just been using this sheet of OSB that I can kind of slide in and out between the shelf. There we go, kind of slide. Inside, I mean, it's just right now a nice big blank wall. We have one window and a bunch of outlets. My workbench that I had in here is going to get shortened a little bit and like skinnier because this room actually got a little bit smaller, so we wanted to make the workbench take up a little bit less space. But that'll go right here, and then we have plenty of outlets on a nice 20 amp circuit that I can run things like my grinders and stuff on. This room, the goal is to get this fully enclosed to protect the machines out there from stuff like the sandblast cabinets. As a bonus, the air compressor is now in a room, not just like in the other side of the shop. So that means it'll be much, much, much quieter out there. And that's actually why I have my fake door right now, is because it does make a huge difference with sound. Now we are going to put a vent in this wall here to be able to vent stuff outside if we're running something really bad, like the blast cabinet. Someone did point out that putting the air compressor with in the room with all the dirty stuff might be bad for the life of the air compressor. So I may look into upgrading the filter here. And when I'm doing the really nasty stuff like sandblasting, I'll turn on that vent and vent everything outside. Everything is still very much a work in progress, but the workbenches have rearranged so that there is now kind of a little cell in front of the house. That is where I do the majority of my work, and I was really tired of walking to the toolbox that was in front of the Tormach over here. Keeping things tight just saves wasted motion. The rest of my shop is still in disarray because, like I said, nothing is actually finished yet, including, but not limited to, cleaning up all the tools and stuff after all the construction work. So while the mill's still cranking away over there, I figured I would show you this flux work holding plug and why I decided to use it. So first of all, you notice here, it's not just like a cylindric pin, like a precision dowel. It's actually domed. And that makes it so much easier to pull out of the fixture plate, or to put in for that matter, because you don't have to worry about getting the alignment just perfect. So I really like that. And it's also threaded, which means when you pull your fixture up off the fixture plate, the pin goes with the fixture. It doesn't stay stuck in the fixture plate, which is handy. Though do notice, so this is threaded here, obviously, like I was just saying. You cannot do precision locating off of threads. There's just too much wiggle in there. They aren't precise enough. But if you look really carefully, right there, there is a angled, like, straight section. So that's not cylindric. That is conical. And just like your favorite tool holders, the conicalness aligns the pin. The cones mate together and align the pin in X, Y, and the well, X, Y, and Z, actually. Cones do all three, and the holding force is just provided by the thread. The thread does not provide any location. It just provides holding force, like the drawbar on a mill, and the cone provides all of the locating that you need. Now, that's not very controlled in the Z-axis, but in this case, we don't care about that because the surface of the fixture plate is providing our Z location. I'm going to use two of these pins, one on each side of my fixture, and I'm going to take one of these and I'm going to take it to my belt sander and turn this into a diamond pin. Basically, I'm going to take off like 5 thou from this side and this side, like opposing sides 180 degrees apart, so that the pin only makes contact on the left-right motion, and that will prevent over-constraining our fixture. If you don't have one of the Flux vices, you can buy these directly from Flux Work Holding on their website. I really like these. Not sponsored. I like the guy who runs Flux Work Holding. I've had him on the podcast, but no money has changed hands. We're thread milling. I think this is the last operation. The first stop is done, but this is weird. We have some of my adaptive finish left over here, and the final finish over here. So like this is the floor finish I use, but there's some adaptive finish left here. I don't know why. That's weird. My guess is I had my coat a little bit wrong here, and it plunged a little bit as it was cutting, and because this is so far off of the parallels, I bet it tilted my stock a little bit. Fortunately, after that, I stopped it and then redid these bores. That means that these right now should be parallel with the axis in the machine. And just my floor was a little bit off. It tilted by what appears to be about 5,000, since that's how much I left to finish the floor here. So I'm going to rerun this floor-facing pass here, and that should fix the issues. Maybe change my speeds and feeds a little bit. I don't love that finish everywhere. We can, however, still test the fit of the chuck, since that is our end goal after all. This isn't a lathe. We don't need any precision fitting here for this to work, but, well, it does need to fit. Okay, so we're a little bit too tight, and we need to fix that floor. So we can do both of those in the same program. Let me check my hole alignment. Well, at an eyeball, it looks fine. I should be able to get these in here. Let me check the threads. I have a thread gauge, but might as well just use the screw that we're going to use. Okay, that seems fine. Alright, so I just need to give myself a little bit more clearance on the outside of this boss and reface these just a tad. And here's a preview of what the finished thing is going to look like. By sheer dumb luck, it happens that the key is right here at the side, which is convenient, though I can tell you right now, I'm going to need to do something about that. That's not going to work. Maybe I'll get something put together for my torque wrench. But everything fits. So now we just need to flip it and do the backside. Obviously, I'm going to take this off first. So I think I figured out why this was able to tip in that last operation. This right here was the end of the bar, and if you look here and here, these are some pretty big high points. I'm sure it has something to do with how the bar was made, and I think this gave it a tipping point that the stock was able to teeter on. And now we're machining the backside. Not much going on in this operation, basically just facing it off and doing some deburring. I have made a mistake. So I started this, and then I walked away, and I came back, and this is what it looks like. So I let the whole program run without me here, and it did not machine off the top. The bores are there, the threaded holes for the locating pins are there, some of my fillets are kind of there, but there's this little onion skin, and of course this is not faced here. I know what the problem is. The problem is that I set my work coordinate system wrong. Out of habit, and just according to my SOPs, I set my work coordinate system at the bottom left corner of the material, or of the part. Now remember, all of this stock down here is gone. We are just left with this here. The problem is, I touched off on the top of my parallels, which are on this surface here, but the work coordinate system in CAD is on this surface. I just didn't think about that, and obviously it came back to bite me. So, we need to fix this now. I don't really care about the thickness of this part. It's just a fixture. It doesn't matter. But I do care about the parallelism, and that should still be fine. Nothing should have changed that. The problem is these threaded locating studs. So when I try to thread them into their holes, they don't go. And upon further examination, because of these meaty chamfers for the locating conical thingy on the locating studs, the thread mill actually did a double blind thread, I guess we could call it. The thread is starting a little ways inside the part, on the real part out there. And what that means is I can't test fit my locating studs because there's no threads to screw them into at the top of the hole. I've never thread milled this specific thread before, so I don't know if my pitch diameter offset is perfect, and I can't test that right now. The problem is if I just shift my work coordinate system down, it's going to move the start position of that thread. And if I had to open up the thread a little bit more, it would double thread it or cross thread it basically. So as I see it, I have two options here. I can either step down in one thread increment. This is a 3/8 24 thread, so I can step down by 1/24 of an inch. Or I can change my cam, fix the thread with it as it is now, and then do my test fit and then machine off some of the top. I think it'll work better if I step down by the 1/24 of an inch, and then if I need to go back and fix that thread, I should be able. So in my offsets page in Z, I'm going to go minus 4166. Is that too many decibels? There we go, 416. and just shift that a little bit. My error was actually a lot bigger than 0.0416 inches. It was about a little over 1/8 of an inch. But again, thickness on this doesn't matter. And in fact, any extra thickness we keep should be fine. So I'm going to go ahead and shave off the top of this fixture, and hopefully we can resolve this without any further issues. I'm starting to regret making this fixture. I'm running out of time, and I should have just made my part. All right, hopefully this first cut's not too violent. That's my biggest fear. Or, you know, it just won't cut at all. I suppose that's an option too. I'm going to shift down by another 1/24 of an inch. I did change the code so it would skip roughing, but do several step downs on my finishing pass. So it's possible that the second finishing pass would actually remove material, but I'm not convinced that it would. So to save time, I'm just going to go ahead and step it down again first. All right, second try, same thing. Wrong move, there we go. This should remove material, hopefully not too much. I'm really bad at eyeballing whatever a 1/24 of an inch looks like. I'm going to do one more, and if that doesn't remove material, then I'm just going to let it go to the other passes. Actually, no, I changed my mind. What I'm going to do is I'm going to go into cam, and I'm going to remove the extra step downs. Now that we know kind of where the material is, I don't really see any risk of taking too big of a bite. And again, same work coordinate system, just no finishing pass. And by finishing pass, I mean roughing pass, but apparently it doesn't matter. And again. Hey, now we're cutting. All right, well, now we wait a bit. And I guess I'm gonna go get some coffee while that runs. I should have just made my part, but our fixture is done. After all that worry about the threads and making sure I could dial those in, they're fine. My little locating studs sit in there just fine. So we should be ready to, well, tear this all down and then run my actual part. Before I forget, I need to turn one of these pins into a diamond pin, and I'm going to do this one for no reason other than it's right here. And I'm going to mark the sides that I don't want to be removed. So this is what I'm keeping, and I'm going to remove some material right there and right there. And this is a great opportunity to use my brand new grinding room for the first time. To remove this material, I want to be really gentle and I want to leave a good finish, so I'm going to use this Scotch-Brite pad on my buffer. I don't remember what these are called, but I like these little clampy things for holding small pieces when I modify them on a belt sander or a buffer. You just kind of put your part in there and then drive this wedge in, and it does a shockingly good job at holding your material. And that's all it takes. The only other thing I'm going to do is this still looks just like the normal locating pins, and I don't want to like reuse this in the future and get it mixed up and think it's one of the like full cylindric pins. So I'm going to take a file and just on the top here give it a little bit of a line just to kind of show me that something's different about this one. To show future AJ that something's different about this one. And here's the finished fixture on the machine. Obviously it's not screwed down yet, but look at this. Super easy to get off, super easy to get back on, but there is zero wiggle, and that's why I love those flux locating pins. I'm very happy with how this turned out and how easy it is to get on and off. Using a Fixture traditional dowel pins, I mean, it works just as well, but it's just way more annoying to move around like that. So I need to get this bolted down, and then we can start on our part. I believe that when the world gets better at manufacturing, the world becomes a better place. And that's one of the reasons why I am sharing these YouTube videos. Obviously, I'm not making a big dent in that, but I think little bit by little bit, we can improve how we make stuff as a society, and that just makes more stuff freely available for everybody who needs it. Now, if you want to make one of these fixtures, I'm going to share these. I'm going to make them open source, public domain license. So if you want to make them for your own use, if you want to sell them, whatever, you can find a link down in the description below to be able to get them. I will include both my CAD and my CAM files, but on cam, I'm going to zero out all of the speeds and feeds on my toolpath, just so that nobody accidentally forgets to change something and uses toolpaths that aren't appropriate for their machine. So the toolpaths will be there, the feeds and speeds will not be there. Also, on that note, to keep things simple and short for this video, I'm going to break this video here, and in my next video, I'm going to make the part that I need to make.